Hello everyone, welcome to my channel. In this video I have this algebra question to work on. So it is given that a plus b equals 9 and ab equals 8. The question says, without finding the numerical values of a and b, determine the numerical value of a minus b. So we are required not to solve these two equations simultaneously, but somehow determine the value of a minus b. So how do we approach it? Well, here is the approach. Taking us to page 1 here, we are given that a plus b is equal to 9 and ab equals 8. So we are required to work out the numerical value of a minus b. So here is the approach. Now squaring both sides here gives us a solution. So we're going to take a plus b being equal to 9, we square both sides. So that equation implies a plus b squared equals 9 squared. On the left hand side, if you agree with me, we have a squared plus 2ab plus b squared equals 81. Now notice something. We are told ab is equal to 8 there. So we can replace ab, replace this one here by or with 8. So we have a squared plus 2 times 8 plus b squared, and the answer is 81. Now what do we have? We have a squared plus b squared will be equal to 81 minus 16, because 2 times 8 is 16. And what do we have? We have a squared plus b squared is equal to 65. When you subtract 16 from 81, you get 65. Why is this important? Well, it's important because now if we take what we are given, a minus b, they are asking us to determine the numerical value of this. If I square this now, I'm going to get a squared minus 2ab plus b squared. Now you see what we have there. Now we have we can rewrite this to a squared plus b squared minus 2ab. And if we take this to page 2, taking this to page 2, you will agree with me that what we have now is, let me put this in order. What we have now is the following. We have, this is page 2. What we have now is, remember, we have a minus b all squared is equal to, let me just carry that one down here, a squared plus b squared minus 2ab. Now we just worked out a squared plus b squared. Here it is, a squared plus b squared equals 65. So we have to replace this with 65 and then minus 2. Remember, ab is 8. We're given that right at the start there. ab is 8. So we put 8 there. And so what do we have? We have 65 minus 16. And the calculator here would say 49. So what are we saying? We are saying a minus b all squared equals 49. And you can agree with me that if we take the square root on the left hand side of a minus b all squared, the answer will be equal to plus or minus the square root of 49. And this cancels that. So a minus b must have a value of plus or minus 7. The question required us to work out the numerical value of a minus b, and that's exactly what we've done, without knowing what a is and without knowing what b is. I hope you found that useful. Tell me what you think. What would be the approach that you would take to solve this algebra question without actually determining the values of a and b? I've had to square both sides of the first equation here and then work on what we produced in terms of a squared plus b squared and also ab. Alright, I'll stop here. I'll see you in the next one.